At sunrise, 20 bird species build nests within a few hundred meters in a quiet forest. A woodpecker chisels a deep cavity in a dead tree trunk, working steadily for several weeks. Hanging upside down, a bird weaves grass into a hollow ball nest that swings gently on a thin branch. A bird lays camouflaged eggs in a shallow scrape on the ground, hidden among dry leaves and grass. By a stream, a bird mixes mud and saliva to build a flask-shaped nest chamber pressed onto a rock face. High in the tallest tree crown, a bird stacks heavy branches into a large platform nest used for generations. A bird quietly deposits an egg into another species' nest, then vanishes forever in an act of brood parasitism. 6 birds use different nesting methods, but all share the same goal: to raise their offspring safely. Animal Mindshift explores what happens inside living creatures' minds during important decisions, asking new questions weekly. Across the globe, 11,000 bird species build nests in uniquely different ways, showing vast diversity. Evolution has solved the nesting challenge in 11,000 distinct ways. Birds answer 4 key questions about predators, weather, food, and materials when nesting. Different bodies, predators, food sources, and habitats lead to unique nesting solutions. Each nesting strategy fits a specific set of environmental conditions perfectly. Most songbirds build cup-shaped nests hidden deep in dense foliage for concealment. Songbirds hide their nests deep in dense foliage to avoid detection by hawks, snakes, and climbing mammals. Cup nests often rest at 3-way branch junctions, where sturdy limbs provide stability against the wind. Nearly half of all bird species build some form of concealed cup nest, found across forests worldwide. Woodpeckers and other cavity nesters excavate deep holes in dead trees, known as snags, to raise their young. Dead trees called snags serve as valuable nesting sites for many bird species within the forest. Standing dead trees act as natural bird hotels, housing generations of different species over time. Small entrances and deep darkness inside cavities shield vulnerable eggs and chicks from predators. Limited cavities spark fierce competition, as different species fight for these scarce nesting holes. Breeding success inside cavities is much higher than in open nests, offering safer shelter for chicks. Some birds build nests on thin outer branches, using weight limits to exclude heavier predators nearby. Thin branches cannot support predators heavier than a few dozen grams, physically protecting nests from harm. Nest movement on fragile branches alerts parent birds early to approaching threats, prompting swift reactions. The fragile branch bends and swings away under a predator's weight, using physics to exclude heavier threats. Nests at branch tips face full exposure to wind and rain, demanding exceptionally strong construction to endure. Weaver birds weave intricate nests, carefully interlacing grass strands to resist seasonal storms of wind and rain. Some birds nest directly on the ground without shelter or height, relying entirely on camouflage to stay hidden. Ground nesting birds lay eggs patterned and colored to mimic pebbles and dead leaves on the forest floor. Mother birds remain perfectly still during incubation to avoid detection when predators are nearby. Some mothers feign injury by dragging a wing, calling pitifully to lure predators away from their nests. These deceptive behaviors show birds anticipate predator reactions and plan carefully to protect their young. Thousands of seabirds nest tightly packed on sheer cliffs, safe from land predators by their inaccessible location. Large colonies of seabirds defend themselves by mobbing predators together, using their numbers to drive threats away. Sociable weavers build enormous communal nests from grass, housing hundreds of pairs across many branches of a tree. These weaver nests are inherited and continuously occupied for over a century by many generations of birds. For sociable weavers, the nest is both home and cultural inheritance. a living monument passed down through time. Megapodes incubate their eggs using heat from decomposing leaf mounds instead of body warmth. Male megapodes monitor and adjust the mound's temperature daily to keep eggs incubated just right. Long before humans invented air conditioning, megapodes mastered natural temperature control. Megapode chicks hatch fully feathered and can fly within days, emerging independently from the mound. Cuckoos lay their eggs in other birds' nests and abandon all parental care afterward. Parasitic birds remove host eggs from nests before laying their own to improve survival chances. Cuckoo chicks instinctively push host eggs out of the nest alone soon after hatching. Host birds feed cuckoo chicks despite their larger size and the heavy burden this creates. Hosts and cuckoos have co-evolved egg recognition and mimicry over tens of millions of years. Nesting strategies are genetically encoded in each bird species, guiding their behavior instinctively. Each bird chooses a specific nesting spot within its species' usual habitat range, making an individual decision. Over 2 to 7 days, birds visit multiple potential nesting sites, carefully inspecting each before settling. At each site, birds assess sightlines, foliage density, signs of predators, and how close food sources are nearby. Birds often choose nesting sites where others of their species are already present, drawn by their neighbors' presence. They use the presence of others as public information, signaling safety and food availability in the area. Birds follow a simple rule called win, stay, lose, shift. They return to nesting sites that succeeded and abandon those that failed. Birds remember past breeding outcomes and adjust their future nesting choices. They hesitate at failed sites before moving on. Eagles and albatrosses reuse nests for decades, building massive sites passed down through generations. These nests show long-term fidelity. Nest building often serves as a courtship display. Males weave intricate nests while females watch closely to evaluate their skill. Female weaver birds inspect the woven nests carefully. They tug at strands and reject nests that do not meet their standards. Male wrens build multiple fake nests to impress females, who then choose the best one. Bowerbirds build decorated galleries instead of nests, arranging bright blue objects as mating displays. Some bowerbirds steal decorations from neighbors to enhance their own mating galleries. Nest structures act as extensions of the builder's body during courtship displays. Nest choice influences genetic parenthood and reproductive success in many bird species. Some birds select nest materials with antimicrobial and antiparasitic properties to protect their young. European starlings add aromatic herbs like yarrow and mint to their nests to reduce parasites. House sparrows tuck cigarette butts among twigs in urban nests to repel insects and parasites. Amazonian birds carefully place stinging ants in their feathers to kill parasites naturally. The choice of nest materials shapes the microbial environment experienced by offspring during development. Small birds often build nests near raptors to gain protection from other predators in the area. Raptors deter predators but avoid hunting near their own nests, creating safe zones for smaller birds. Some birds nest near wasp or fire ant colonies to deter climbing predators effectively with their defenses. Choosing a nest location depends on the entire surrounding ecosystem, not just the single tree itself. Humans began placing wooden nest boxes that meet birds' evolved nesting criteria to aid breeding success. Birds often breed more successfully in plain wooden boxes than in natural tree cavities. Birds use evolved criteria, like a mental checklist, to evaluate natural or artificial nesting sites. Nest boxes have helped prevent extinction of many bird species through conservation science worldwide. Concrete swiftlet houses mimic natural caves to attract swiftlets for nest harvesting in tropical areas. Swiftlet houses maintain humidity between 75 and 95%, temperature 26 to 29 degrees, near total darkness, and high ceilings. Speakers inside swiftlet houses play calls to lure wild swiftlets by exploiting conspecific attraction. Swiftlet nests, made entirely of saliva, sell for thousands of dollars per kilogram in a global multi-billion-dollar industry. Swiftlets have abandoned natural caves and now prefer artificial buildings for nesting, shifting their habitats dramatically. Rapid human changes create ecological traps that mislead birds' evolved instincts, putting them in grave danger. Mowed lawns seem safe but hide a deadly hazard, as machinery destroys hidden ground nests without warning. Glass reflections cause an estimated 1 billion bird deaths worldwide each year. Non-native plants attract birds, but do not support the insect food their chicks need. Birds now nest earlier in spring, but insect food peaks remain unchanged, causing mismatch. Chicks hatch after insect abundance peaks, risking starvation in the nest. Bird instincts cannot adapt as fast as rapid human-driven environmental changes. Each nest is a species-specific solution, crafted to meet unique survival challenges and risks. Nest location solves a complex equation of predators, climate, food availability, and building materials. Birds choose diverse strategies: concealment, fortresses, branch tips, ground nests, cliffs, or mounds. Each bird surveys multiple sites, evaluates sightlines, and learns from past outcomes before settling. Birds select aromatic herbs, cigarette butts, and stinging ants to reduce parasites and disease in nests. Choosing a nest means balancing predator risk, weather exposure, and resource availability in the forest. Bird brains under 1 gram make complex decisions, carefully evaluating where to build their nests. Humans once believed only they made complex decisions, but now this assumption is questioned deeply. When birds evaluate nesting sites, they show a genuine form of mind and true cognition at work. Across 11,000 species, each bird mind uniquely solves survival problems in its own way. 11,000 species of birds quietly make decisions every day, building futures for their next generation. Observing a nest reveals complex survival strategies and the deep cognition behind each careful decision. Every nest tells a story of evolutionary adaptation and the choices made by its builder to survive. Nesting reflects each species' unique logic, shaped by their ecological and behavioral needs. Birds place nests to exclude predators, using strategies that protect their vulnerable offspring. Nests are carefully built to shield eggs and chicks from harsh weather like wind and rain. Birds select nest sites close to food sources, ensuring they can feed their young efficiently. Nest building depends on finding suitable materials like twigs, leaves, and mud nearby. Instinct guides each species, but individual birds make specific choices about where to nest. Birds inspect many possible sites, sometimes up to 20, before choosing a final nest location. Birds carefully assess signs of predators, like tracks or markings, when choosing nest sites. They measure the density of leaves and branches to ensure their nests stay well concealed and protected. From different vantage points, birds check sightlines to avoid being spotted by lurking predators. The distance to food and water shapes where birds decide to build their nests for easy access. Birds also watch for others of their kind nearby, using their presence as a sign of safety. Birds use public information by observing the behavior of others in their species to guide their decisions. Many birds remember past breeding outcomes and return to those sites to improve their chances in future seasons. Some species show site fidelity, reusing nests year after year when breeding has been successful before. When breeding fails, birds often abandon those sites and search for new locations to build nests again. Over decades, some nests grow heavy and large, as layers of materials accumulate on sturdy branches or cliffs. Some bird families inherit nests, reusing them across generations to shelter their young. For many species, building a nest is part of courtship, where males weave intricate homes to attract mates. Females inspect these nests carefully, judging their quality as a sign of the male's fitness and skill. If a nest fails inspection, males often tear it down and rebuild it, trying again to win the female's approval. Some males create several fake nests, displaying them to females to increase their chances of selection. Bowerbirds create elaborate structures, arranging bright blue objects like an art gallery in the forest. Some bowerbirds steal shiny decorations from neighbors, carrying out daily heists to improve their mating displays. A bird's nest acts as an extended phenotype, a body extension used in courtship rituals and mate evaluation. European starlings carefully select nest materials for their antimicrobial and antiparasitic properties. These starlings add aromatic herbs like yarrow, mint, and lavender to nests to reduce parasites effectively. House sparrows tuck cigarette butts into their nests, using the smoke residue as insect repellents in cities. Amazonian birds carefully place stinging ants among their feathers, harnessing formic acid to protect against parasites. The choice of nest materials shapes the microbial environment that influences the health of the chicks inside. Some small birds build nests near raptors, using the predator's territorial behavior as protection from other threats. Raptors avoid hunting near their own nests, creating safe zones where smaller birds can forage with less danger. Nesting near wasp or fire ant colonies deters climbing predators effectively, providing a natural shield. Birds choose nest locations based on complex interactions within their ecosystem, balancing shelter, food, and safety. Humans create artificial nests, replicating natural criteria to support bird conservation efforts in changing habitats. Simple wooden boxes with carefully sized entrance holes keep nests dry and reduce parasites for small birds. Birds raise more chicks successfully in artificial boxes than in natural cavities, aiding conservation impact. Birds do not distinguish between natural nests and artificial ones when selecting their homes. Nest boxes have helped save many bird species worldwide from extinction by providing safe nesting sites. Swiftlet houses, often multi-story concrete buildings, produce nests for $1 billion global market. These swiftlet houses mimic caves with humidity between 75 and 95%, temperatures from 26 to 29 degrees Celsius, and near total darkness. Speakers inside swiftlet houses play calls to attract birds, using conspecific attraction to encourage nesting. Swiftlet saliva nests sell for thousands of dollars per kilogram, fueling a global market. Natural swiftlet caves are often abandoned as birds shift to nesting in artificial buildings nearby. Birds misled by outdated environmental cues face increased mortality and ecological traps caused by humans. Mowed lawns mimic grasslands but destroy camouflaged ground nests, creating hidden dangers for birds. Glass reflections cause massive bird collisions, killing around 1 billion birds worldwide every year. Non-native plants attract birds to suburban gardens, but these plants fail to support their chicks' dietary needs. Birds now nest earlier in the spring, but insect food peaks remain unchanged, causing a mismatch in timing. Chicks hatch after the peak of insect abundance, risking starvation during their critical early days. Bird instincts shaped over millions of years cannot keep pace with human-driven changes happening in just hundreds. A close look at a bird's nest reveals complex evolutionary and behavioral adaptations at work. Each bird species solves survival challenges with its own unique nesting strategy, shaped by nature. Many birds hide their cup-shaped nests deep within thick green leaves to avoid hawks and snakes. Cavity nesters like woodpeckers chisel deep holes in dead trees called snags to protect their young. Some birds build intricate nests on fragile outer branches, keeping heavier predators away by weight limits. Ground nesting birds protect camouflaged eggs by feigning injury, drawing predators away with broken wing displays. Colonial seabirds nest densely on sheer cliffs, safe from predators by the cliff's inaccessibility and strength in numbers. Male megapodes build large leaf mounds that heat from decomposition, carefully monitoring temperature daily to incubate their eggs. Brood parasites like cuckoos lay eggs in other birds' nests, abandoning all parental care and leaving others to raise their young. Individual birds choose specific nesting sites within their species' usual range, selecting spots carefully for their own needs. Birds visit many sites over days, inspecting sightlines, foliage, and signs of predators before settling on the safest spot. Birds often gather near occupied nests, using the presence of others as clues about safety and food nearby. Some birds remember past breeding success and return to the same nest if it brought good results before. Nest building acts as courtship, with females inspecting male nests and prompting males to rebuild if rejected. Birds choose nest materials like aromatic herbs, cigarette butts, or stinging ants to repel parasites and protect chicks. Wooden nest boxes mimic natural cavities, meeting birds' needs and helping improve their breeding success. Swiftlet houses mimic natural caves using concrete walls, keeping humidity between 75 and 95% and temperature from 26 to 29 degrees Celsius. Speakers play calls to attract the birds inside. Rapid environmental changes create ecological traps that mislead birds. Mowed lawns destroy nests, and reflective glass windows cause fatal collisions. Climate change causes birds to nest earlier, but insect populations peak unchanged. This disrupts food availability for hungry chicks waiting in their nests. Nests reveal species-specific evolutionary adaptations. Each construction reflects decisions made to solve survival challenges unique to that bird. Birds show learning, memory, and decision-making when choosing nesting sites. Their complex cognition guides these vital behaviors. Birds pause thoughtfully, evaluating nesting sites with complex decisions in tiny brains. This is the mind shift concept. 11,000 bird species each build unique nests, showing diverse cognitive solutions to their nesting challenges. Birds silently make complex nesting decisions that shape the survival of future generations in quiet forests. Observing nests reveals hidden complexity in animal behavior and the survival strategies they depend on. Each nest reflects a species-specific design, shaped by survival challenges and adaptation to its environment. Birds carefully place nests where predators find it hard to reach or see them. Dense leaves and hidden branches help keep nests safe from danger. Nest designs change with the climate and available materials. Birds build sturdier nests in windy places and waterproof ones where rain is frequent. Birds watch others of their kind to choose nesting spots. Seeing where neighbors settle helps them find safe and resource-rich places. Some birds return to the same nest year after year. They remember past success or failure and change their nesting choices accordingly. Male weaver birds weave intricate nests to attract females. The females inspect these nests carefully before choosing a mate.
Birds choose nest materials not only for strength, but also for medicinal benefits, like antimicrobial herbs, cigarette butts that repel insects, and even stinging ants to control parasites. Humans create artificial nest boxes that mimic natural sites, helping bird populations by improving breeding success in gardens and parks. Swiftlet houses imitate natural caves, using dim lighting and acoustic lures from speakers to attract birds for nest harvesting industries. Human changes create ecological traps that mislead birds, like glass windows reflecting sky and trees, causing fatal collisions and destroying nests in mowed lawns. Climate change causes birds to nest earlier, but insect food peaks remain unchanged, risking starvation for hungry chicks waiting in their nests. Bird evolution struggles to keep pace with rapid changes humans impose, causing instinct mismatches. Nests reveal much about a species' ecological role and cognitive traits through their unique designs.
Birds show complex cognition when choosing nesting materials and making survival decisions. Bird minds form a continuum of cognitive complexity, varying widely across different species. Each bird species solves survival problems uniquely through its own nesting choices and strategies. Birds make silent, complex decisions that shape their futures and those of their offspring. The world is full of minds quietly thinking, deciding, and choosing every moment. We rarely pause long enough to observe the minds at work in the natural world. Nests embody evolutionary, ecological, and cognitive complexity in every species. Consider the minds of birds anew and appreciate the depth of their quiet intelligence.